Alright, here is a quick video on finding length of an arc. Arc obviously belongs to circles. So if you have a little circle here, let's say the radius of the circle is r, and let's say we have an angle theta that's being made at the center of the circle, then s is basically the length of this arc, and we call it s. S corresponds to the angle theta that is being made at the center of the circle. So given r, which represents the radius of course, s represents the length of an arc, and theta represents the central angle, or the angle that's made at the center of the circle. One important thing that you want to verify and keep in your mind and register that this theta has to be in radians. This formula only works if the angle is in radians. So if the angle is given to us in degrees, our first step will be to convert it to radians, which we learned in the lesson. And then there's a separate video posted of how to convert degree to radians and radians to degrees. So one more time, this is how theta, the radius of the circle, and s are correlated. It is also very interesting to note that let's say I create another little arc. Let's say this is, if this is S1, let's call this S2 or just S1. And then if this angle is, let's say, theta 1, then it's very interesting that the ratio of the angles will be the same as the ratio of the arcs created by those angles. It's just very interesting. They are proportionate. So if I were to look at an example, I could have a very simple example. Find the length of the arc whose radius is 4 meters and has a central angle. So theta, central angle, is also given to be half a radian. And the question is, find the length of the arc. Okay, if you were to look at it visually, they're basically saying the radius is 4 meters. And for an angle that's about 0.5 radian or half a radian, what is S, which is this arc length? Right? And we already, so the formula here would be length of the arc is basically just the product of the radius and the angle itself. Very simple little formula. Length of the arc is theta times r. I'm going to use that. The best part here, theta needs to be in radians, and it is in radians, so I don't have any conversions to do. Radius is in meters, which is what it should be. And when I go ahead and multiply both of them, half of 4 is 2. The arc length is 4.2, and it is also going to be in meters, because the original question was in meters. See how easy that was? How can it get any complicated? Let's say we have a picture drawn. And this is missing. And the question is, find the length of this arc. So you want to register that theta is 60 degrees and r is 6 centimeters. And the question is, find the length of the arc. Now, again, theta needs to be in radians, but in this case it is given in degrees. So I have some work to do before I can actually use that formula. 60 degrees need to be converted into radians. If you remember, going from degree to radians was, each degree is pi over 180 radians. So 60 degree would be 60 times pi over 180. When you start simplifying this, 60 goes into itself one time, into 183 times, and the conversion is pi over 3. Now that I have the angle in radians, I'm going to substitute that, fill in the radius. Now since radius is in centimeters, my length automatically will be in centimeters. The 3 goes into 6 2 times, so the answer is 2 pi, and just 2 times 3.14, which is about 6.28 centimeters. That would be the length of that arc. Here's another example, and it may or may not be drawn for me. Just trying to find a good example. Alright, let's say we have the radius given to be 5 meters, and let's say theta is given to be so 30 degrees. Okay, and the question is, what would be the length of the arc that is made by that angle for a circle of radius 5 meters? And I would want to say that, well, there's a simple little formula for that. You just take the radius and multiply by theta. However, some little work needed on the side. Theta is not given to me in radians. I'll do that little conversion. 30 times, if I do pi over 180, that will automatically convert it to radians. 30 goes into itself one time, 6 times, so that's pi over 6. Then I come back and I go, radius is 5, theta is pi over 6. Just pick up your calculator. This is basically 5 times 3.14 divided by 6. .617-ish, and this will be in meters. Alright, this is how we find length of an arc given the radius and the central angle. Only catch is, keep in mind that the central angle needs to be in radians. Here we go. I'll see you in the next video. Bye.